Hey Chem fam, we are back and we are learning about molarity and we're just starting off. But this is question number 6 on molarity worksheet number 1. Let's take a look at it. First of all, it says in order to prepare a 2 liters of a 3 molar solution, first of all, we know the volume is 2 liters and that the concentration or the molarity, capital M, is 3 molar solution. And we're going to make that of ferric chloride. Now, ferric chloride, as it says, is FeCl3, which is iron 3 chloride. We want to know how many grams of FeCl3, or iron 3 chloride, would we need to dissolve into that solution. Okay, so there's a couple things we can do. First of all, we know the equation for molarity is the moles of the solute divided by the liters of the solution. Okay, so can we plug into that at all? Absolutely. We know our molarity already, it's 3 moles. We also know our volume is 2 liters, and that means that if we plugged into that, we would get the moles of solute. Now, is that what I'm looking for? Not quite. I'm looking for the grams of solute. So let's solve for moles of solute, and once we get that, let's convert that to grams of iron 3 chloride. So it's like a 2-step problem here. Don't get overwhelmed though, it's no big deal. So let's start with part A. Let's plug in to this equation right here. So we've got 3 for our molarity. We don't know how many moles of solute we have, so that's X moles over 2 liters. All right, to solve for this, literally all I have to do is multiply 2 to both sides. That cancels out, and I'm left with 6 for my answer. Now remember, because we're solving for this top part, that answer ends up being in moles. So you have 6 moles of the solute, which is FeCl3. Now that we have that, is there a way to convert that to grams? And oh baby, there is. It's from good old-fashioned mole map conversions. So let's take our answer, which is 6 moles of iron 3 chloride, and let's convert that to grams. Oh my goodness, it's all coming back to me now. All right, I need to get rid of moles, so I'm going to put it on the bottom, and I need to get grams of it, so I'm going to put that on top. So I'm going to label this, again, bottom is getting rid of the moles so that the moles on top and bottom cancel, and we're putting grams on top because that's what we're trying to solve for, of iron 3 chloride. All right, oh my goodness, where do I go next? Where do I get these numbers from to fill in this conversion? Don't panic. Remember, if you look on the periodic table, for every 1 mole of iron 3 chloride, there's a certain amount of grams. If I add up 1 iron and 3 chlorines, that will give me its molar mass. And if I do that, if I add all that up, for my periodic table at least, I get around 162.2 grams of iron 3 chloride for every 1 mole. Moles cancel out, I'm left with units of grams, and now this just becomes 6 times the top number, which is 162.2, divided by the bottom number, which really you don't have to do because it's divided by 1. But 6 times 162.2 ends up being about 973.2 grams of FeCl3. So what does that mean? That means if you had a big beaker with 2 liters of water, you would take 973 grams of iron 3 chloride and mix it in there, and if you did, you would end up with a concentration of 3 for its molarity. All right? So you start thinking about not only the numbers, but what does this stuff mean? Again, it's how much our grams that we would measure out in the lab would be dissolved in that much liquid to give you a molarity of 3. All right, so that's a good start. Hopefully you followed with that. If not, no worries, we're learning. Let's keep continuing and see where we go from there. All right, let's look at number 7. What is the molarity? So that means we're looking for big M, or the concentration. What's the molarity of a solution produced when you have 14.1 grams of ammonia, all right, that looks like a mass of the solute, all right? If you have 14.1 grams of ammonia is dissolved in sufficient water to give me a 0.1 liter solution. Okay, so what does that mean? 0.1 liter solution is my volume of the solution. All right, I'm dealing with molarity, and I know that molarity is going to be the moles of the solute divided by the volume of the solution. Problem is, I don't have moles of solute, I have the mass of the solute. So before I can solve for molarity, I've got to get my mass of solute converted into moles. Good thing I know my good old mole map steps. If I have 14.1 grams of ammonia, I'm going to get rid of the grams and convert that to moles. Why? So that I can plug it into the equation. And that's what I'm going to do. I'm going to look at my periodic table. For every 1 mole of NH3, if I add up 1 nitrogen and 3 hydrogens, I end up with a molar mass of about 17.04 grams. Again, off my periodic table. Yours might be slightly different because periodic tables can round. Now, grams cancel out, so I'm ending up with 14.1 times 1, because it's on top, divided by 17.04 on the bottom. That's how you make that work. And the answer I end up getting is about 0.83 moles of the solute. Remember, the solute is the thing that gets dissolved, and that's of ammonia. Now that we have that, we can plug that in here and figure out our full answer. So let's do that. Molarity is going to end up being 0.83 moles on top, that's of the solute, divided by the volume on the bottom, which we were told is 0.1 liters. Do that divided by 0.83 divided by 0.1, and you end up with 8.3 molarity as your answer. Now remember, big M, the units, also stand for moles per liter. So you could write this answer as 8.3 moles per liter or 8.3 capital M. Both are acceptable. But do you see the trend here? You need to be able to convert back and forth from mass to moles or moles to mass. And as long as you can do that using dimensional analysis, meaning that you know that you have to get rid of grams, so you divide by grams and get moles on top, and you can use your periodic table. As long as you can do that, then we're just literally plugging into a very straightforward equation, which is molarity is equal to the moles of solute divided by the volumes of solution. All right? Hopefully that helped walk you through a couple more problems with a little more support. Keep trying, plug away, try out the problems, check the answer key, look for your little mistakes. Where is it that you're having trouble? And we can focus in on that and discuss that together as a group. And that way we get better. Focusing on our weaknesses allows us to learn better. So nice job, JChem fam. See you soon.